Hi everyone, hope you're doing well. I can't believe it's almost April. I wanted to make another update video before the expo. I will be presenting at the expo with some of the team in June, so I'm very excited about that. If you haven't watched the previous video from January, try to watch it. I know it's very long, 27 minutes, but there's a lot of information on that video. But just to summarize, we're making the 757 a high fidelity aircraft. It's going to be the best 757 ever created. That's our goal for Flight Sim, right? And there's a lot of people on the team that are passionate about the plane. There's also a lot of outside help from pilots, mechanics, engineers, and enthusiasts that are helping us along the way to make sure that this is the most epic 757 ever built. I also want to emphasize that with the new programming team starting back in September, their focus is really make sure that it performs well on any computer that can run MSFS. So that's really something that's important to us, and I want to highlight that because I know I've gotten some questions regarding that. The other thing is, as a company, BlueBird, we're not going anywhere. We're here for the long term. We have a pipeline of projects that we have planned, but right now the focus is on the 757. And also the 767, but 90 plus percent is on the 757, with the 767 slowly getting developed in the background. But this video is just going to cover the 757. What separates BlueBird also, I want to point this out, and what's taking so long for this project is because we're one of the few companies that's making an airliner from scratch, from the ground up. That includes the model, textures, flight dynamics, and the systems, right? So that's why it's taken a long time. But this will prove advantageous in the future because the code that we're building now is a foundation that we can use for any aircraft from various manufacturers, right? So this is what we're developing right now. We're getting through the hard part. And the 767, I think, is going to come to market a lot sooner than some people think. I also want to shed some light on the circuit breakers. We understand from a pilot's perspective that they're rarely, if ever, used. We have several pilots on the team that tell us this. But I want to just, from a developer's standpoint, just mention the reason we implemented the circuit breakers is when we started the systems from scratch back in September, we were rebuilding the electrical system. We had all the documentation. It made absolute sense to include the circuit breakers. Mapping the circuit breakers to their respective electrical bus, we did that last year. There's 500 circuit breakers. We mapped to over 20 electrical buses on the 757 that the buses supply power to the systems. We did that in about 2 weeks last year. That was the tedious part. Now what we're doing is, as we're completing the systems where we can, we're going to hook those systems up to their respective circuit breakers. That is not something that's going to hold up the release of the plane. We can always add more circuit breakers after release. And to clarify, not all 500 breakers are going to work on release. We're hoping to have at least 100. But again, we can add more circuit breakers after release. But I really want to quickly just go over why we added the circuit breakers. It's also kind of like if you're rebuilding your engine, you're going to go in there and replace all the gaskets and seals and bolts while you're down in there. And that's the same principle here with the electrical system. It made absolute sense for us to add the circuit breakers. It didn't take that much time, and it's an extra feature that we thought we wanted to add because it just shows the attention to detail that we have. All right, now let's get into some of the meat and potatoes of the video. We're going to start off with the sounds. Boris has done a great job. We're just going to preview some of the sounds. These were all recorded from a 757. I'm really excited to finally preview these to you. Great job, Boris, and all those sounds, just amazing. I really get goosebumps listening to those RB211 sounds. We're going to pay the same attention to the Pratt & Whitney sounds as well, so don't worry, we're going to preview those at a later date. Now let's show just a small feature we implemented with the windmilling, and I'll explain this more in the video now. All right, here we are parked at LAX. We're roughly pointed north. You can see the fans are not spinning. I'm increasing the wind speed, and this is a headwind now that's coming straight at the plane, and you can see the fans start to slowly increase their speed to windmill with the wind. We're going to play this in real time, that way I'm not cutting through the video. You can see what's going on in real time. And now I'm changing the direction of the wind to be a tailwind. You're going to see the fan slowly stop. We have, a physics and inertia model here for the engine fans to kind of react to the wind. And they're going to start spinning in the other direction, windmilling in the other direction. .85 knot wind. It's a little too much there. It's also worth noting that the direction of the wind, one engine fan may spin faster or slower depending on if the direction and the fuselage is going to block some of that wind going to the other engine. So they're not going to spin at the same speed. All right, now we're just going to move it to be a crosswind. And again, now since this is coming from the side, the fans are not going to windmill. We have almost a 26 knot crosswind. And you can see the fans slowly stop because the wind is not affecting them. So I hope you enjoyed this little windmilling demo. Now we're going to show the air conditioning system on the 757, which has been modeled to a very high level of detail. Keep in mind that this is still a work in progress, but I wanted to give you an idea. And we're hoping to keep this video shorter, but we think it's important that we show you the whole thing. So it's 12 minutes long, just this segment alone on the air conditioning system, but really just shows you the level of detail that we have in the systems, and it's just a preview of what the other systems are going to be like in the airplane.
Welcome to the BlueBird Simulation 757. My name is David. I'm one of the developers that's working on the 757 as a programmer and texture artist. And I've been working on the air conditioning unit. So what I'm going to do now is walk through some of the modes and functionality of the aircon under different conditions, just to give you a small glimpse into the kind of depth that we're going into for these kinds of systems throughout the 757. So at the moment, the aircon is set up with the APU running, and hot bleed air is being transferred through the APU bleed air valve into the left and the right system. So the packs are then cooling this hot bleed air. So this cool conditioned air is transported through the ducts from the left pack into the flight deck. It is then passed through the electronic and equipment cooling section, which is underneath the flight deck, and then into the mixed manifold, and then back through all of the ducts into the cabin. And it sort of has a cycling effect throughout the whole jet. So the right pack is cooling the hot bleed air also, and because we have the isolation valve open, that hot bleed air is able to get through to the right hand pneumatic system. Like I say, the right pack then cools it, and then it's transported through into the cabin. It's also mixed with hot trim air, which again comes from the source at the moment is the APU, and the trim air allows the cabin valves to open to regulate the temperature such that it maintains whatever is on the control, whatever is selected. At the moment, when it's on auto, it means that all of the sections will try to go to 24 degrees Celsius. So at the moment, this is all in development, and you have to ignore this current switch position, because when it's in the cold position it should actually be 18, and when it's in the warm position it should be 30 degrees Celsius, and obviously off is just off. Off means the valve should turn off. So if I rotate this knob down, then eventually we hit the left hand side, which if I was to rotate even further would go into off. Like I say, ignore the rotation of this knob. At the moment it is actually in the off position, so if I select it one up, we'll go into the cold position. So that means that the valve is now open, it's supplying hot trim air into this area, and slowly the air will distribute around and try to maintain that 18 degrees Celsius in the cold position. So as I try to increase this, and I go all the way up to 30, which again one more click would get us into the off position, so come back one and we'll go into the warm position, which is 30. So now the flight deck is trying to heat up to the 30 degrees Celsius. And as it does that, it's using this hot bleed APU air. So if I turn off the trim air, that turns off all of the valves in that area, and all of the sections, zones as we call them, can't heat up. They have no hot air going into them, so they all cool down. Now if I turn that trim air back on again, slowly the valves will open back up, and we have also modelled these valves to actually be valves. When you are operating these buttons, you are actually operating valves and various pneumatic systems that function exactly like the real 757 does. So these zones start to heat up. So at the moment the recirculation fans are turned on. So this is recirculating air from the flight deck and the forward cabin through the electronic and equipment bay underneath the flight deck. So at the moment the outside air temperature is 32 degrees Fahrenheit, which is 0 degrees Celsius. So if I go and open up, well, first of all what I'll do is I'll turn off the trim air so that there's no hot air can get to these areas, and I will open up one of the windows. So now I've opened up one of the windows, and now you'll see that the flight deck starts to cool down. Remember that all of the zones will cool down because there is no hot bleed air getting to any of the sections, but the flight deck window is currently open, so therefore it cools down faster. If I allow hot trim air to come in again, then again these will heat up. As the air moves around, this can also, primarily it should cool down, but as it's mixing, you get variability within the system. Just give it some time to change. So now what I can do is I can also heat up the cabin to be warm. So let's move that around to be 30 degrees Celsius. So again, that hot trim air is going into the cabin. Remember the flight deck window is still open, so it's cooling, but it also is getting hot air. Now if I rotate this around such that that valve actually closes, so it becomes in-op, then now we've got no hot trim air going into that section, and the window is currently open and it's 0 degrees Celsius outside, so this starts to cool down quite rapidly. Now at the moment the flight deck door is closed, so therefore there is some mixing that goes on in these areas, but if I go and open up that door, which I'll do now, there you go, the door is now open. Then what we see is that this here will generally try to heat up to match this, and this will cool down to average out to that. So together, the air is now able to mix. The aft cabin section, it also is far enough away that it should actually stay warm. Remember, all I've got open at the moment is the flight deck window. So if I close the cockpit door, and I'll also close the cockpit window, then again that mixing still occurs. But if I also open up this valve now to go back to 18, then this starts receiving hot trim air from the APU. These are going to 30 degrees Celsius, so therefore it all starts to heat back up again. So if we go and change the outside air temperature so that it is very hot outside, then now remember that all of the doors and the windows are closed. So therefore, because it is a closed system, these are very slow to react to any kind of outside air temperature change. But as would happen, because the outside is hot and the internal flight deck is currently 18, so it's it's not 35-40 degrees Celsius. It starts to heat up gradually. Now if I open up the flight deck window again and now monitor the temperature in the flight deck, then that hot air from the outside is now able to get into the flight deck. So we notice that this flight deck will start to heat up a lot now. So if I also turn off the left pack, this stops cooling the hot bleed air, and there is no air that actually gets through into the flight deck. So this will heat up a lot faster now because there's no air conditioned air getting to there. So I'll bring down the temperature of the cabin. So they're all set to 18 degrees Celsius. Again, ignore the rotation. It is actually on 18 on cold. But again, this left pack is disabled, so therefore there is no cool air coming to this flight deck, other than maybe what would go into the mixed manifold from the right pack. So gradually they start to come down. Again, the flight deck remains hot because of this left pack being off, and if I turn it back on again, it cools the air and it'll start to bring down this temperature. Now if I turn off the isolation valve, then that means the hot bleed air that comes through here does not get into the right pneumatic system, and that will cause this right pack to turn off. So the duct pressure is going down and the right pack will now turn off. I'll also turn off the APU hot bleed air so that none of them get any air. Again, duct pressure falls and the left pack will now turn off. So thank you for joining me for this small showcase of just the aircon unit and some of its modes and functionalities, and we'll see you in the next one. Cheers.
Thank you, Dave, for that explanation. A lot of work has been put into the air conditioning system, as you can see. It's pretty much 95% done. It needs a few tweaks here and there, as Dave has mentioned, still a work in progress. We didn't even cover the rest of the pneumatic system or the cabin pressurization system. We'll cover that in a later video or maybe at the expo. But again, this gives you an idea of the level of detail that we're going into with the systems. Also, I hope you noticed the disclaimers on the textures that I put in the video. These VC textures are not the textures. These are just placeholder textures and colors. The version 5 VC textures are being worked on. In the next 2 to 3 weeks tops, they're going to be complete. And we're going to showcase those at the expo. And they're looking phenomenal. Let me just say that. Speaking of the expo, again, I'll be presenting there. Some of the team will be joining me. I'll see if I can force them on stage with me. But we'll be going through the 7.5 and 7.6 projects. I'll see between now and then if we can do another update video. If not, we're going to really try to go a little bit more in depth again at the expo on the projects and just giving more insight on the development process. I'm really looking forward to it. I've never been to an expo, so I think it's going to be a great time, and looking forward to seeing as many flight simmers there as I can. Okay, with that said, we're going to wrap up this video. It went a lot longer than we wanted to, but I think it's important that we share as much information as we can. We're not sharing everything yet, right? We're kind of doing it in stages. Also, I still get a lot of questions on the release date. In the beginning of the year, we said we're hoping to get this thing out by the end of the year, right? That's still our goal, but I want to make this clear. If we have to push it back into 2025, we will. We're not rushing this. We're making great progress, but there's, something can happen that can push this back a little bit here and there, but it's coming out. Like I said, we're not going anywhere. BlueBird is here for the long term. We've got a long pipeline of projects that we're looking forward to, and the 757 is just the beginning, So I really appreciate all of the support. I really do. It means a lot. Thank you so much, and we'll see you next time.